Okay, and these first four terms we got from our point in the y value. And this is just the way we notate them. So the first term in sequence S is 3. The third term in function S is 12. The fourth term in function S is 24. Okay? What we want to find is the sixth term. So we want the fifth, and then we want the sixth. Okay? To do that, we want to find a pattern here. So what am I doing to this term to get to the next term? So in other words, how do I go from here to here, and from here to here, from here to here? Okay? So think about it is we want to figure out the pattern. And our weapons to figure this out, just kind of like we did before with the x values last week, when we write rules, we want to use this. What am I using operation-wise? So which one of these allows me to get to the next term? Okay? So if you look at that pattern, what we're really doing is we are multiplying by 2 each time. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So now that we know the pattern, we can easily find the next number in our sequence. So 24 times 2 is, throw that in your calculator. It's okay to use calculators. 48. So that's term 5. Multiplied by 2. And now to get to term 6, we multiply by 2 again. So if you do this correctly, term 6 is 96. And now we have the first 6 terms in our sequence. Okay? And this is a sequence. Remember, the sequence is just our outputs, our y's. All right, the other thing I want to talk about, and if you saw the video, you should also know this. This is one way of writing the terms. So the first term of sequence S. Okay? This is called subscript notation. So I'll write that here. That's subscript notation. But you can also have function notation. So we still use the same letter S, but now this is what function notation looks like. Let's do a different color. Let's do purple. So this is function notation. So it says we're using the function S and we're doing the first term. So you write it as a function. S, we're plugging in. Think of it this way. We have S, and we want to plug in the fourth term. We want to figure out the fourth term. S, we want to figure out the fifth term. And S, we want to figure out the sixth term. This is function notation. It's important that you know both types. They pretty much mean the same thing. The video does a good job of explaining that. Okay? So whether you're given the red version or the purple version, it means exactly the same thing. Okay? All right. Let's jump to number 2. Describe how you go from one term of the sequence to the next. So we kind of did that already, but we're going to write it out in words. So how do I go from the first term of the sequence to the next? and we figured out that we are multiplying by 2. Okay? When we get more and more into sequences, this idea of finding the pattern is probably the hardest part of the whole thing. Once you find the pattern, it's pretty easy to set up. Okay, so now let's go ahead and look at number 3. So they want us to find the 7th term in sequence S. Okay, so I'm going to write that out just so you understand what it's asking. We want the 7th term. And when I say term, it's basically the 7th number on the list, 7th term of function or sequence S. I use function though. We got to get used to using function. Okay, so to do that, if you look, we already got the 6th term. So I'm going to write this in. So 3, 6, 12, 24, 48, 96. And now we want S of 7, or the 7th term in our sequence, in our function. So we already know the rule. We're just going to multiply the previous guy to get the new guy. So in your calculator, we're going to multiply by 2. Okay, if you do this correctly with your calculator, 96 times 2 is 192. So the correct way to write this is S subscript 7 is equal to 192. That's the 7th term in our sequence. All right. Hopefully we're following along and we're pretty comfortable with this. Now it says find S of 10. Okay, that's how you would say that. This is 7th term of function S. We want S of function, or 10th of function S. So I'm going to write what that says. Okay, but it just means the same thing. We really just want the 10th term. Okay, so we know S of 7 is 192. So let's find the 8th term. So take out your trusty calculator if you have one, and we know how to get to the next term. We just multiply by 2. So here to here, multiply by 2. And if you get your calculator out, you have 384. Okay, we have to go to S10. So we need 9. The 9th term in our sequence. So multiply again by 2. And we get 768. S10 multiply by 2, 1536. So the way we write it is S of 10, or 10 of function S, is 1536. Okay? So once you get that pattern down, it's as simple as multiplying. If the pattern's addition, it's as simple as adding. Okay? Next step, describe how the graph changes from one term to the next. So let's look at the graph. How does it change? Okay? So when we talk about graphs, we use a vocabulary word. When we talk about changing in a graph, we talk about this guy. Okay, so get used to using that rate of change. So if you look here in the graph, let's look at this visually. Is the graph going up like a line? Okay, does it go up like a straight line, or does it have, it gets, as you go to the right on your graph, is it getting higher faster? Okay, if it looks like a line to you, then we would say the rate of change is constantly increasing. Okay, that's when your rate of change looks like a line. If you connect the dots, does it look like a line? In this case, this would not be the correct answer for our graph. Okay, the rate of change does not look like a line. In fact, if I connected these dots, it looks like a curve that's going straight up. Okay, so when that happens, we describe the rate of change differently. So we would say the rate of change is increasing okay, that's all we can say right now. Rate of change is increasing. It's not constant. Okay, it doesn't change like a line. It doesn't look like a line. So rate of change is increasing. If you want to be more detailed, because you might be asked to do this later, you could put the more to the right we go, or our graph goes, the larger the increase. So the higher my graph goes. That's kind of how we say it in math. Okay, so the more to the right, the larger the increase. So again, this is just, hopefully you're starting to see a pattern here, because when we talk about sequences, it's all about patterns. Okay, depending on what the graph looks like, you're going to have a certain type of sequence. Okay, and that's what we're going to learn the next coming weeks. Can you look at the graph and say, oh, this is this type of sequence, or it's not this type of sequence? So I just want you to understand that there's different types of sequences. Okay, so that's what we had to do for number 1. Hopefully it wasn't too difficult. Okay, so to summarize, a sequence is what we've been working on, a function. Okay, and the sequence is essentially just the output of our input-output table. So if you notice, it's just the y values. Okay, we talk about the y values in the word using terms. So term 1, and there's 2 different notations for that. Term 3, 2 different notations for that. And then we could also see a pattern on how to get the next sequence. In this case, we use multiplication. Rate of change is, how does my graph change? Is it going up? If it's going up from left to right, it's increasing. Okay. If it's going down from left to right, it's decreasing. If it's going up like a line, that's constant. If it's going down like a line, that's a constant. Okay? If it has a curve, it is not constant. The rate of change is not constant. All right? So again, just some vocabulary words that we got to be comfortable with. So saying that, I'm going to go ahead and show you the next set of problems. Okay? So you are given a sequence here. Here it is, 1, 7, 13, 19. I want you to go ahead and do 6 through 10. Okay, I'm going to give you some time to do it. And then if you finish this early, start working on the calendar problems. But we are going to return back. Let's shoot for 10:50. Okay, and we're going to talk about these problems. Be ready to share some of these answers. So return at 10:50. I will be here if you want to stay on. Again, if you finish early, work on the calendar stuff, and then I will give you the access code when we return. The rest of the time until 10:50 is yours. Use it however you'd like, but go ahead and do 6 through 10 now. Okay, so describe how you go from one term of the sequence to the next. So let's look at this sequence up at the top here. Let me just write it for you. So it's 1, 7, 13, 19. Again, I always try to do adding first and see if it works for the rest of the sequence. So if you do here, we're adding 6. So if it works for the next one, in the next one we found our pattern. So 7 plus 6 gives me 13. 13 plus 6 is 19. So we are adding 6 to get to the next term in our sequence. Okay. Cool. So we got that. So just to get comfortable with the notation, all right, if you look at problem 7, we're calling this function k. All right, so this is function k. That means this is k1, this next guy is k2, k3, and k4. Okay, so again, I'm using function notation here. You could also use subscript. All right, so how do we figure out problem number 7? We want K12. So what we're going to do is, with our trusty calculator, if you have it, pull that bad boy out, and we're going to add 6 until we get to the 12th term. Okay, so 19 plus 6, that gives me 25. 25 plus 6, that's 31. 31 plus 6, I'm trying to write small so I can fit this in. 31 plus 6 is 37. 37 plus 6 is 43. 43 plus 6 is 49. All right. Let's continue the sequence here. 49 plus 6 is 55. 55 plus 6, 61. 61 plus 6 is 67. So let's see what we have. That's K4, K5, K of 6, K of 7, K of 8, K of 9, K of 10, K of 11, and we found K of 12. So K of 12 is 67. Okay. For 8, we got to find K subscript 15. So the 15th term of the K function. So we just continue. So 67 plus 6 more, 73. That's K of 13. 73 plus 6 more, 79. K of 14. 79 plus 6 more is 85, and that's K of 15, or K subscript 15. So K subscript 15 is 85. Okay, so once you find the pattern, it might take a while, but you should be able to find any term you want. All right? So this head over here, if you were on Zoom earlier, I kind of explained this, but I'm going to re-explain it. Okay? So if you look at our sequence up top, we have 1, 7, 13, 19. So let's go 1, 7, 13, 19. Okay? If we wrote this as an input-output table, so let's write this as an input-output table, because that's what a sequence basically is. It's our output. All right. So our input, so here's our output, here's our input. So our input would be our terms. So if you look here, this is going to be my first term. Term 1, term 2, term 3, and term 4. So this is a sequence in input-output form, okay? And if you recall, if we have an input-output form, we always could turn input and output into a ordered pair. Our input is our first number, and our output is our y value. So our inputs are x value, our outputs are y value. This one could be turned into 2, 7, and so on, okay? Where the confusion comes in is this guy right here, okay? What this guy is saying is our order pair, we're used to calling it X and our output Y. That's what we're used to. So our order pair will be X and Y. But in function notation, when we're dealing with function notation, we can change our variable, our input variable. Instead of X, we could call our input variable N. So instead of X here, it's really, we'll call it, our input variable, we'll call it N. Okay? And when we're dealing with function notation, usually our output is Y, but now with function notation, because we're dealing with a function that has a name, and the name of the function is K, we want to use function notation. So instead of Y, what we're really saying is, we have a function K, and these represent the term when we plug in the letter N for it, or we plug in the number N. If you look, these are the number N's. So if I plug in 1 for N, my output for this function would be 1. If I plug in 2 for N, my output would be 7. If I plug in 3 for N, my output would be 13. But it doesn't change the fact that we can still plot these. So instead of thinking this as X and Y, what this problem is asking you to think of is function notation. We're going to call the X, now we're going to call it N, And the y we're going to call k of n. Let me put it on the bottom so it's better. N, and this guy's k of whatever n is. Okay? But it means x and y. Input, output. We're just renaming them. That's all it means. So if I had to do all my points, this would be 3, 13. This would be 4, 19. Okay? And then we would graph this using a graph. So let me just graph that really quick. And I'm just going to sketch it. So it's not so accurate, but you get the idea. We'll go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, something like that. Okay, so these are going up by 2. 2, 4, 6, 8, 10. Okay. So if I was graphing the first one, 1, 1, it'd be right here. 2, 7 would be slightly above the 6. 3, 13 would be right above the 12, something like that. And then 4, 19 would be way up here. Okay, and it would look like a line. All right, so that's how you graph it. Don't let this confuse you. It's just calling x and y by a different name. We're using function notation, which you should be comfortable from Im3. If not, we're going to get a lot of practice of it anyway. Describe how the graph changes from one term to the next. So the graph, remember, we want to use rate of change. So the rate of change for my graph okay, so is my graph going up or down as I move from left to right? So it's going up. So the rate of change is increasing. And then the next question, is it constant? Does it look like a line or a curve? If it's a line, we would use the word constant. To make it grammatically correct, increasing constantly. Okay, so make sure you check